Hey there, today we'll be doing this question that's 890 find and replace pattern, and the question statement is given a list of strings, words, and a string pattern, return a list of words of I that match pattern. You may return the answer in any order. A word matches the pattern if there exists a permutation of letters P so that after replacing every letter of X in the pattern P of X, we get the desired word. So let's understand this question better. So you will be given a words array and a pattern which is string. So how do we say that this pattern is matching this word? So taking on the first example, let's just say A, B and C which is in the word, and the pattern that we have is ABB. So what we will do is we'll just map A with this index, we'll map B with this index character, and mind you we have already mapped B with some character, right? So again we cannot map B with some another character. So that means you can only map a character to some character once. That is, it should be a one to one mapping. Okay, it cannot be a one to many mapping. That is, B cannot be mapped with something like a B also and a C also. Okay, so it can only be mapped with one character. Okay, and sorry for the noise, it's raining outside, that is why. Okay, so just bear with me, it will be a good explanation. Okay, so now coming on to why do we get mee and AQQ as an answer. So if you just see right here, that's mee, and you try to map out ABB, then what do we get? A is mapped with M, B is mapped with E, and again you see that B is mapped with E already, right? So you do not need to map this. Why? Because B has already been mapped, and next time when you see a B should be mapped with E, you see that B is already mapped with a character E. So no need to map this character. So every mapping is possible in this case. So that is why we just return a string that is mee. Okay, and why not something like a DKD as our answer? Let's check onto that. So if we have a string such as this, that is DKD, and our pattern is something like ABB. Okay, so A is successfully mapped with D, which is perfectly fine. Now B is mapped with K right here, right? And previously I said there cannot be a one to many mapping. That means once B is mapped with something, it cannot be mapped with any other thing, right? So again we see that B is being mapped to D here, which is not possible. So that is why this is not included in our answer. Okay, and let's just take one more case right here, that is this CCC, and this question will be clear to you. So if we have something like CCC and the pattern right here is ABB, what do? We just map A with C, which is perfectly fine. Now again, if we come right here, we see B is mapped with C. Now what is the problem in this test case? Now uh, in the question, it's been stated that a character should be mapped to one character, which is perfectly fine. But there cannot be another character which is mapping to the same character which has already been mapped. So let's understand this phrase or whatever the sentence which I just told you right now. So A is already mapped with C, okay, which you have maintained in some data structure. Let's just say for now, okay. A is already mapped with C. Now you cannot just say that B, which has not mapped with some other character, can also be mapped to C. That means if A is mapped with C, you cannot have any character which maps to C again. Okay, so this is what I'm trying to explain. If I just say it in a simpler word, okay, you cannot have some character which are mapped to the similar characters. Okay, so you cannot have a relation something like A and B and both are mapped to C. Okay, that is many to one. So these are the things that you need to take care of it. And how we gonna do it? It is just a simple brute force approach that we'll be following here. That is, we'll first iterate on the words, okay, and we'll just try to map every pattern with every word, okay, and we'll try to check if all of the necessary conditions are meeting. And what are the condition? The first condition is that one character should be mapped to only one character. Okay, this is the first condition. and that is all, I think. And if you just talk about the condition which should not happen, it will be more clear to you, I guess. So we just need to check here for the condition which should not happen. I'm trying to tell you those things, okay? So this will be more clear to you. That is, two characters cannot map to one. This should not happen. Another thing is, one character should not be mapped with two characters. Example for this is, let's just say A is mapped to C and B is also mapped to C. So this condition should not happen at the first instance. And the second instance is wherein, let's just say C is mapped to A also and C is mapped to B also. Okay, so these are the two conditions that you need to take care of. That should not happen. Now let's get to the code part directly, because that was the intuition behind on how to do it. Okay, you just need to simulate this process. So we'll first be going through the words array, okay, which I just told you. And this function is what will give us that can we add this character to our answer, sorry, the string to our answer or not. Okay, this function, now what this function is doing, I'll be explaining it to you. So this function is taking two parameters, that is the string in the words array and the pattern which is provided to us. Now let's check what this function does. So coming on to the function, we have created a map and a frequency array and a value which says can't. Okay, now what this function does is it will go on to the string word by word and check. And how will it check? So I'll just take another example right here. I'll just take it from here only. So something like, let's just say a word which is forming, AQQ is forming, and the pattern given to us is A B B. So I've declared a map data structure and also a frequency array, right? So I'll just bring this down here for your reference and do this. Okay, so what happens in this for loop and if part is, we are iterating on this words array, that is AQQ, that is given to us, that is our word, and this is our pattern, that is ABB. So I'll be iterating on here. So I'll go on to here and also here, and I'll check, can I map this? Okay, so this is the part wherein I check it, that if my pattern can be mapped or not. So I'll just check if I've already mapped this pattern or not, or this character or not. So if the value is 0, that means it has not already been mapped in my map, right? And I will also check the frequency. What does that mean? We'll get onto it later when you dry run this DKD example. I'll be doing that also. Okay, for now let's just focus on this part right here. So A has not been mapped. So in my hash map, what I'll be doing, I'll just map A to A. Okay, this is my hash map right here. Now I come to this part, that is B and Q. Now is B mapped already? Obviously not. So what I'll do is, I'll say, B, you go and map yourself with Q. Now, while I'm doing this mapping, I'm also making sure that the frequency has been increased by 1, since I have used these characters to map someone with someone. So A has been mapped and B has been mapped. So the frequency of A and B in my array has already been increased. That is in this part wherein I'm doing it. Fine. So A and B has already been done. Now when I come on to this part, that is B, I see that it has already been marked, right? It has already been mapped to something which I know of. Now this is wherein the checking part comes into play. And what does this check function else if part do? It just simply says, okay, you already have a B in your map. Is it actually mapping with the same character which you had already mapped in the map? That means B was mapped with Q. Now when I'm in the third position, that is this position, is this value actually equal to this value which is present in your map? If it is not equal, then only you'll return a false and you just break out. Otherwise, the loop completely ends. The loop will run, it will end, and it will return a true. And you can add this EQQ string to your answer, which is also present in an answer array, right? So this is the basic part wherein it does not involve any frequency checking. Now, where does this frequency check-in come into play? Let's take that example. So let's just say some example as DKD or CCC. We can also take a CCC example. Let's just take a CCC and A, B, B as an example. Now let's see. So we come first here. A is mapped to C, which is perfectly fine. This has been mapped. Now we come to B, right? Now when we come to B, we see that it is not already present in my map, obviously. But remember, I am also maintaining a frequency array. And what is that frequency array saying? It is saying that these characters which are present in the word have been used. That means while I mapped A to C, I also made sure the frequency, let's just say these are the frequency A, B, C, and so on till Z. Okay, I am incrementing the frequency. So I've used C once. I know of it. Now, when I come to this B part, I see in my hash map it is not present there. I can map B with someone. I know that someone cannot be C. And how will I know that? From my frequency array. So my frequency array will say me, okay, if someone is not present in my hash map, who can I map it with? And it will tell me you cannot map with C. So this part is saying frequency of words of I. That means it says you have already mapped C with someone. You cannot do it. So it will go into the else if part. Again, B is not present there, and the frequency is more than one, right? So that means you cannot use this C to map with B. So this B will not be mapped with C. Now this B will also be not mapped with C, and we will just directly return a false right here. Okay, and this is how the whole code works. Okay, and if everything works perfectly fine, we just return a true. And what does this true mean? If it is a true, we just push it back into our answer vector or an array. Okay, whichever you feel like doing. But since the return type is vector, I just took a vector, obviously. And at the end of the day, you just return the answer. Okay, so I hope the whole code and the explanation was perfectly fine and you have understood the solution, and this is a perfectly running code. I've already submitted it. Okay, I've already submitted right it here. Okay, so yeah, this is it for this video, and if you did enjoy and understand the explanation, please do like and subscribe, and yeah, thank you for watching.